Welcome to Future Energy Insights, the podcast series that explores the future of sustainable innovation, brought to you by the World Future Energy Summit. In this episode, we'll explore the future of waste management as expectations rise around the circular economy and use of waste to energy. As the global shift towards a circular economy accelerates, the waste management industry faces a defining challenge. How does it eliminate landfill reliance while ensuring sustainable, efficient solutions? I'm Rob Jones, partner at B2B Connect, and joining me for this episode, we have Tim Clark, CEO of Wasson Waste Management Company, and Daka El Rabia, CEO of Waste Processing and Treatment at BIA Group. So Tim and Daka, thank you for joining us. We'll start with a look at the circular economy, where and how waste management is changing because of greater emphasis on the circular economy, and work our way through to waste to energy. So a question for both of you, and I'll start with Tim and then Daka, you step in as well. With that greater emphasis on recycling, reuse, how are changes to waste management happening? How is the planning for waste management changing?
Well, I think a few things specifically in Dubai. Obviously, Dubai municipality sets the pace and the strategy for waste management. At the moment, they've chosen to build the energy from waste plant to deal with 45% of the waste from Dubai. But obviously, in their strategy, they need to look at zero to landfill by 2030. So they need to develop other avenues. So yes, there are a number of other things, the recycling and repurposing of things, resources out of the waste that you can extract, the paper, the plastics, the wood. Obviously looking at how you can segregate those, whether you can do it at source, whether you can do it in plants that segregate before the energy from waste process. But there are a number of things which you can take steps to do, which are well-trodden paths in Europe and America, but early days here. So I think there's a lot to be developed in dealing with segregation, separation of waste and reuse of waste before you get to the EFW plant.
Okay, and Daka, for you as well, as we start to see more emphasis on the circular economy and the different aspects of the circular economy, again, how is waste management planning that collection and what happens to that waste changing?
I would like to take a couple of minutes first to explain the difference between circular economy and recycling. When we talk about an ideal circular economy, we're talking about a resilient system that can reproduce the same amount of products without accessing more natural resources from the upstream and without emitting and discarding waste to the environment from the downstream. So circular economy is a very challenging concept and it needs a very robust strategy. You need first to create products that last forever, that can be passed from one generation to another. You need to design and build products that can be easily repaired, modified, upgraded. Then you need products, if the first and the second stages are not appropriate, you need products that can be repurposed easily for another use. If all this is not applicable, you need products where you can use some components to be used in other products. So you need the product to have components that can migrate from one consumer product to another. And when all this is not applicable, you need to make sure that you create products that can be fully recycled. So as you can see, recycling comes last. In an environment where many of the preceding stages are not yet mature, definitely the reliance on recycling becomes huge. And when BIA was established from day one, our target was to ensure that landfill will disappear. We will not be relying on landfill anymore. We had an ambitious target to achieve that in 2015, but being really pioneers, we had to learn the very hard way. So we went through all the challenges, and definitely it became evident that 2015 was a very challenging target. But interestingly, on the way, we eliminated a lot of waste. So, for example, we have not been sending any construction and demolishing waste to landfill for more than 7 years. We have no issue anymore with waste tires. electronics, we already achieved almost 70 to 80% of recycling of all types of commercial and industrial waste. It has been more than 2 years now since we ever sent hazardous or medical waste to landfills. It's recycled 100%. And as we move, definitely the challenge becomes more and more. And this is where the waste to energy or energy from waste fits in as a last stage in this hierarchy. And we move on as we face new challenges to modify.
So what's happening to that waste now? You said that there's a number of different types of waste that are not going to landfill. How are they becoming a resource? What happens?
So first of all, we act simultaneously on two directions. We act on the direction of communicating to people, businesses, introducing a lot of awareness programs. But on the other hand, we don't wait until we get the results. We modify our processes. We introduce more facilities to deal with the tiny part of the waste that is remaining and still going to landfill. And actually, this is how we reached a concept where our landfill becomes an industrial area with 11 facilities tackling different types of wastes. And we still plan for another 2 to come. And we will have another phase, which is phase 2 of waste to energy.
Okay. So what you're talking about then is value generation. You're both talking about value generation from that idea of circularity and the different phases of circularity. How do governments and industries create those strong, viable markets? Because it's one thing to start trying to do to start trying to find different ways of using these materials, but how do you start to turn that into an industry that makes money, that people will be attracted to, where they'll invest and start to actually put time and effort into? So again, I think both of you.
I think one of the things that's a drag in Dubai on recycling is what do you do with the products that you produce from recycling, the waste plastics, the waste cardboard, the waste wood. If we look at particularly the European model and the US model, they've gradually moved towards businesses wanting to take those products and convert them into resaleable items and creating value. I think one very good one in Scandinavia is a company that takes throwaway disposable bottles and turns them into long-term reusable bottles. So 20 throwaway bottles become one long-term bottle that you can use for the future. So I think these are the kind of industries, companies we should be looking to try to attract to the UAE so that they can actually make use of the segregated products. Once you've got the offtake for a segregated product, then it makes it a lot easier to viably segregate it because you've got a route to actually utilize it. In the circular economy, you need to take the resource that's in the waste, turn it into products that companies wish to use as the feedstock to create the items that people want for the future, or they want to buy. And I think that's the little bit that's missing at the moment in the key, certainly in the UAE.
But there are companies starting to do this. I know of companies that are turning palm leaves into construction materials. We've got companies turning some of the waste materials into tiles and stuff like that. So there are industries looking at it. I guess one of the arguments is if you can make money from it, you'll get more people coming to it. Would you agree?
Yeah. Well, when it comes to Sharjah or when it comes to Bi'a, we were lucky that we foreseen this. We have foreseen this from day one. So we decided to go in a very simple way. This activity can be divided into 3 verticals. One vertical is environmental and social activity. Definitely, private sector doesn't see the direct value to come and embrace the burden and invest. So this is a B2G. Another vertical, which is the what we call the waste management vertical. Waste management vertical means you have to bring the waste, sort it, extract the valuable material, then let's say, transport and dispose the remainings or the residues. We also were very clear. We didn't cheat ourselves. We knew that you will not find an easygoing investor who would come to make characterization of the waste and take all the risk and invest in a sorting facility. And we are sure this is the case, especially when you don't have clear gate fees, tipping fees, strategy that really justifies the investments. Then comes the third vertical, which is the commercial vertical. And when we say commercial vertical, we expect that an investor would come and say, give me your bottle, I know how to recycle it, and I know how to create a value of it. Give me a steady calorific waste with calorific value, moisture content, chlorine, etc. I am ready to put my money and invest, buy from me the electricity, and give me steady supply with a stable gate fee. So what we did is that we took the first and the second stage. So we invested heavily in awareness, in instrumentation to monitor the air, water, and soil quality. We invested heavily in the sorting equipment and the sorting facility. This is how we built more than 11 facilities. And it was really justified, because as long as you created a hub where you have thousands of tons of recyclable material in one location, we started to see that private sector was already encouraged to come and invest in recycling. And for now, I would like to tell you that we have already signed more than 10 joint ventures with investors, where our scope is to secure the land adjacent to the recyclable material. We give steady quality of raw material, and investors are very willing to come and invest. We made it even easier for them using the digital transformation. We own now the biggest platform that trades recyclable in UAE. We even expanded into Saudi Arabia, India, Jordan, Egypt. It is a platform, you can call it let's say the eBay or the Amazon of the recyclable material. So we even augmented the amount of recyclables that we are extracting with the amount of recyclables that we have access to through the platform.
So this platform is obviously a digital platform where people can see the types of waste that are available, and then what they bid on, or they buy that waste by a ton or something.
Imagine, instead of going to Amazon and saying, I would like to search for a mobile phone, for example, and going to that platform and saying, I would like to search for HDPE. And then you find 10 offers, 20 offers. Then you put the price. You compete in a fully transparent way. You compete and you acquire this material.
Okay. And again, by putting everything close together, what you're doing is, which is something that Tim has mentioned a couple of times, you've reduced the transport distances. You've really taken out some of those sustainability challenges, because now everything's in one location.
We actually tackle all the concerns that a recycler would have. So first of all, we commit to the recyclables, that all of them will be delivered to his site. Okay. We tackle the logistics matter. Okay. And he has a stable, not only supply, but a predictable input material prices as well. And when we are part of this venture, so it's our mutual interest to make this business successful. So it's not anymore like a client-supplier relation. Each joint venture has its own board. Part of the board are representing BIA, part of the board is representing the investor, and they all work together. And I think our relationship with Masdar, building the waste to energy, is the flagship of such successful relation and partnership.
Okay, so let's talk just briefly about the part of waste that we're all trying to see eliminated, or at least significantly reduced, and that is the waste going to landfill. So in terms of landfill, are there some types of waste that you simply can't put into the circular economy or can't be put through a waste to energy plant, Tim?
Not in principle, no. Everything is recyclable. There are some elements of the processes and the waste that we generate through the processes, which makes them very, very difficult to recycle because they're either contaminated or they're in a means where it costs you more energy to utilise it than to dispose of it. So there are some outputs which are very, very difficult to deal with. But generally speaking, there is technically a way to recycle and reuse most waste. At the very least, most even hazardous waste can actually be converted into building products, brick materials, provided you can contain whatever the contaminant is within the sealing arrangement. You can actually use it for concrete infill, for building blocks, etc. So there's a route to recycling most items, and most contaminants that you've got in the waste or appear in the ash from the energy from waste process do have a value, but it's difficult to get them out. So, for instance, heavy metals, they're in such small quantities, it's very, very difficult to get things like cadmium and arsenic back out of the waste. So there are some things which are ultimately not practical to recycle at the moment, but that's a relatively small percentage. There is a route to using 90+% of the waste that we currently produce, and if you as was discussed earlier by Daka, if you think about the product process from the very beginning, if you don't put those products into the products that you produce in the first place, then they don't appear in the waste cycle. So going back to the beginning, the troublesome waste you should eliminate in the production process for the initial materials that you're actually producing.
So there's some onus here on the producers of the products to make sure that they're producing products that have a future life.
I think the best example of this is the car industry in Europe about 10 to 15 years ago, where they were set ambitious targets about recycling. At the end of life, a car has to be 90% recyclable. So that made the difference, the choice of the materials that you put into new cars so that at the end of life, they're recyclable. So that's the kind of thinking that you need to embody in the production of everything that we produce so that you minimise the waste at the end of it as well.
Okay. So Daka, that brings us, I think, very nicely to a question which is looking to the future a little bit, which is, are there types of waste that are not particularly a problem today that potentially could become a problem in the future? And when I thought of this, I was thinking of things like waste solar materials as PV comes to end of life, or batteries from, for instance, cars, as they're no longer good enough to drive that car.
Well, first, I would like to elaborate on what has been said right now. So if you're not designing the product to be part of the circular economy, definitely you're producing waste. So you're designing for waste. And as long as this is happening, you will always have waste. From one side, it's good for us. We will have job for the next 1,000 years, but it is really not comforting, because the more development in the technology, the more complex products and the more complex and more composite materials are entering the economy. And you're absolutely right. When we talk about the electronics for now, the electronics components are becoming more and more complicated, and this is why we have a lot of challenges, because we are leaving a lot of heavy metals behind. Let's say when we talk about the automobile industry and we introduce catalysts with a lot of heavy metals, where does this heavy metal go? As you utilize and use the vehicle, do you think that all this heavy metal remains within the container, which is the catalyst? I don't think so. We will have a lot of issues related to the batteries, I think. Big challenge, because again, you have a black mass that contains a lot of valuable material from one side, but from the other side, a very hazardous material and very aggressive to the environment and the underground water. We're talking about the solar panels. I am really anxious to see a valid solution. And we started to pile already the solar panels. I'm talking about the windmills. Same challenge. We have to create a very complex material, very hard to recycle composite material, and then we heroically try to find a solution how to recycle it at the end of its life cycle. So these are mainly the types of waste that I can see put to be the next challenge for us.
And once you start looking at those, you have to start planning for those, I guess. And is this something where the waste management industry is starting to think and plan today because you know it's going to be a future problem?
Well, from a point of view of energy from waste or waste to energy, there is no room for this material to be accepted. It doesn't burn, so there is nothing for you to do. And if it burns, it explodes, on the other hand, and it creates more problems than you can handle. But when it comes to Sharjah, for example, we are also investing in the research. As we speak, we have 3 teams working on different challenges in the universities, and we are dealing directly with these universities. We are participating and funding this research. And we are expecting in 2-3 years to have, let's say, nationally or domestically grown technologies that we will own and will help us to move forward. We are now planning for a big project for the electric vehicle batteries recycling. I think we will launch it next year. All the studies and the feasibility are ready. And I think this way, the next generation can be already recycling these types of wastes.
So actually, it sounds like when you both mentioned zero waste to landfill, if we shoot forwards 50, 100 years, people will look back and wonder, why did we ever go to landfill? It sounds like what's happening now is making zero landfill not a dream, but actually something that could happen, is a reality. Is that fair to say?
I think so. I mean, if you look at Europe, there's quite an emphasis now to mining back out the previous landfills to recover the resources that are in them. As you develop and are able to better use the resources, it makes more and more sense to recover the waste that you've previously buried. So I think it's entirely possible that we can arrive at a close to zero to landfill. I'm not sure we'll ever get there, because there are some things which it's difficult to do something with. Contaminated and irradiated material, for instance. It's kind of difficult to find an alternative for those. So not impossible, but extremely difficult, I think, at the moment. So I think approaching zero to landfill should be the target for every nation, really, because you're basically squandering a resource that you then replace by buying, in the construction industry, primary one aggregates, which you have to mine. You can use ash and you can use other products, the solid products from waste. Similarly with the paper and the wood, rather than cutting trees down, recycle. So it's entirely possible to get close to zero to landfill. I don't know whether we'll, with the current technologies that we have within our lifetimes, whether zero to landfill is ever really truly achievable. But I think we can certainly get 99% of the way there with what we can currently do.
And it's interesting as well. Is it difficult to try and, as societies, difficult to try and make us start thinking resource and stop thinking waste? Dhaka.
As I said, when people shifted from waste management to resources management, that was exactly the intention. When in the 70s, the scientists started to talk about circular economy and circularity, this is exactly what they were talking about. But the issue starts with the design of the products. There is so far, I'm not so pessimistic, but so far I don't see a radical change in the design concept, where a designer starts to think not about how to make the product fancy and how to attract the consumer to buy it, but also what happens after 10 years, 15 years, 20 years. Again, is the product, is it able to be updated instantly and forever? Is the components durable enough, etc., etc.? As long as these practices are not dominant in our life, starting from the design phase, definitely we will have the challenge on our way to zero waste to landfill. I'm not saying that we are not moving forward. As I explained right now, by at this moment, we receive annually around 3 million ton of waste through one gate in Sharjah. 90% is recycled, diverted one way or another. And our remaining challenge now is 10 or less than 10%. Even the bottom ash that we are extracting from our waste to energy facility is 100% recycled. So our challenge is no more than 3% of whatever goes to the landfill, which is the fly ash. And there is another research team working on it. So I'm not saying that we're still in the same place. What I'm saying is that our challenge as waste managers increases by the time if the design phase and the product thinking phase doesn't step in to take more responsibility to produce different types of products.
Okay, so let's turn to waste to energy. And I guess this is the end of the line, anything that can't be found, reused, recycled, etc. So first of all, I think just give a general overview of the size of each waste to energy facility and paint a picture that people could understand. So Tim.
Yeah, well, obviously the Wasan waste to energy plant that has just been built and brought into operation, it's the largest in the world. So it's of a size that sort of doesn't bear comparison with most other energy from waste plants. We have 5 boiler lines, a single steam turbine. We're processing 5,500 tonnes of waste per day and generating 215 megawatts of electricity, which is enough for about 135,000 homes. It's roughly around 2% of Dubai's electricity supply is coming from that waste. Now, the 5,500 tonnes is around 45% of the total waste that's produced daily in Dubai, which is around about 12,000, 13,000 tonnes a day. And of that 12,000 tonnes a day, around about 8,000 is a combustible waste that's suitable to go to an energy from waste plant. So we're taking 5,500 tonnes of around about 8,000 tonnes of waste that's available. So around about 70% of the combustible waste in Dubai is going to the energy from waste plant. Now that's fully operational. We similar to the BR plant, we extract from the waste that's supplied to us the energy, which is the primary benefit of the energy from waste plant. But we also, because we're combusting the plant, you avoid the organic content going to landfill, then producing carbon dioxide, methane and sulfur dioxide, nitrous oxides, which are far more polluting. So in terms of CO2 equivalent, there's around about 2 million tonnes a year of CO2 emissions saving by routing this waste to the energy from waste plant in Dubai. So it's environmentally beneficial in terms of CO2 equivalent emissions. The ash that we produce, we segregate out of that all of the metals. So all of the metals are recycled. So we're producing around 180 tonnes a day of metals to go back into ferrous industries for steel production, aluminium particularly, going back into the aluminium canning industry, etc. And also significant amounts of other valuable non-ferrous metals. We do get an amount of gold and silver out of the waste, rather surprisingly. So we do extract all of the valuable elements of the metal. The balance of the ash then is processed through our plant to turn it into an aggregate grade, which is recycled into the, primarily in Dubai, they're focusing on the Road Traffic Authority and road building. So all of our ash waste, the ceramic part of the waste that's left over from the combustion process, is being recycled into roads building, and as in Sharjah, the only part that we're currently not able to recycle is what comes from the flue gas residue. So unfortunately, when you burn waste as it's supplied as black bag waste to us without segregation, you do have an amount of emissions of the sulfur compounds, heavy metals that are in some of the metals, which is extracted into the flue gas residue. So this is a particulate material which captures all of the pollutants. Now that's around about 3% of the total waste tonnage that we burn each day. So that at the moment we're looking for a recycle opportunity, which I think BR is as well. So globally, this is an opportunity to try and find a recycling element for the flue gas residue.
Yeah, for BR, the waste to energy from day one was planned to be the last in the chain. So our waste to energy facility is a newly born and it started the operations around 1.5 or almost 2 years ago, and we designed it such way that it receives only the material that we gave up on. So the material that goes there has almost zero value to BA, and this is why we have a completely different performance parameters, more steady input, and even much more steady and less output in terms of residue, while we are able to produce bonus electricity. So right now, at this moment, we treat around 300,000 ton per year, and we are considering installing another phase. The only reason why we don't do that is that we want to make sure that the surge in the waste generation that we have seen from 2012 till now is steady, because there are sometimes when we had a real increase in the waste generation, and you don't want to build a phase now and find that it is either partially idle or not enough. I think by the end of this year, we will make up our decision. And in the same time, in our DNA at BIA is that we try to avoid incineration as much as we can. So in parallel, we are working out other routes to deal with waste. So, for example, we are producing now between 500 and 600 tons of alternative fuel that is shipped daily to cement factories to replace coal. We see potential, and we are now also in parallel studying to double this quantity. And in this case, of course, the incineration process will be downscaled. So by the end of the year, we will have this picture clear, and we will be announcing about our next step. What I want to say is that the bottom ash, as already mentioned, is also a recyclable material. And when you feed steady material that has no metals or aluminum or steel or other types of material, it is even more valuable for the construction, for the block production, interlock production. And that was a surprise for us, because usually the designers are used to receiving the mixed waste from the bin directly to the incinerator. And when we started the operations, many of these new findings were revealed, and we are making use of it. And the plant is just functioning in an amazing way.
Okay. Tim, is electricity from burning waste cost comparable, or how can you make it cost comparable to other forms of energy? It's generally thought of as being more expensive.
Yeah, I think rather like we've been talking about the circular economy, you have to look at the entire process to make proper judgments about that. Yes, if you look at the electricity production capacity of an energy from waste facility versus, say, a gas-fired facility in terms of capital cost, or solar or wind, then yes, it would appear to be more expensive. It's around about $4,000 a kilowatt installed capacity, but and that's compared with, say, like CCGT plant around about $800 a kilowatt. But you have to look at the lifetime cost. So we have a negative fuel cost because of the tariff. A gas-fired power station has to pay for fuel. So if you look at 20 years of fuel, then the equivalent capital cost of a gas turbine station is around $10,000 a kilowatt. So that's double the price of an energy from waste facility. If you want to do comparisons with solar and wind, solar you have to install 5 times the capacity, because the solar reliability or load factor is only about 18%. Because it's dark 12 hours of the day, and another 6 hours of the day the sun is too low to actually produce power. So you only get around about 18% of the capacity. So for every kilowatt hour that you generate from an energy from waste plant, you have to install 5 times that amount of solar. So if solar is around about $1,000 a kilowatt, you've actually got to install $5,000 worth of solar panels to be the equivalent of the energy from waste plant. Similarly with wind, because load factor on wind is maybe about 27%, you have to install 3 times as much wind capacity to get the same energy capacity as an energy from waste plant. So $1,500 turns into $4,500 a kilowatt for wind. So you have to make sure that you're looking at the total costs of what you're doing. If you look at it in those terms, energy from waste at the moment is actually the cheapest means of producing power, because you have a negative fuel cost, because it's an income to actually take the waste, because otherwise it's going to landfill or other disposable source. So because of that functionality in the energy from waste process, it makes energy from waste actually a very cheap and viable waste of producing electricity. You also have to consider the environmental factors. So if you look at solar and wind, if you replace EFW and the alternative to that is putting it into landfill, you have to take account of the CO2 emissions. So effectively, if you're looking at displacing EFW with solar or wind, and you put the organic material into the ground, which then decays to produce the methane, nitrous oxides, actually you're substituting around about a kilogram of CO2 equivalent emission for every kilowatt that you generate from a renewable source. So in the same way as everything else, you have to think about the overall circular economy and what it means across the whole spectrum before you can make sweeping statements that EFW is more expensive. It's my belief that it isn't, and if you look around the world, the number of EFW plants that have been constructed, the economics are very strong in this direction.
And I notice you call it energy from waste, not waste to energy.
Yeah, I think this is mainly because waste to energy has a negative connotation. You've got waste and you're trying to do something with it. You know, as we've discussed a little bit earlier, we should look at waste as a resource. So, it's a very valuable resource to the community, what the energy, the materials that are in the waste. So by calling it energy from waste, we're focusing on the fact that we're deriving energy from the waste. It's a much more positive thing. In the same way we can derive the metals from the waste, we can derive other products from the waste. So it's more putting a more positive perspective for everybody in the community to view waste not as a problem, but actually a benefit to society in the long run.
I can even add another perspective now as an economist. The waste to energy is not fairly treated when it comes to as a business plan initially. And when we say, is the electricity price competitive, we're already putting the waste to energy in the wrong context. It's easily figured out by just imagining that you have company A saying, I will treat your waste through an energy from waste facility, and another investor who says, no, let me build a landfill for you. So you make a concession for 20 years with this guy and that guy. This guy who built a waste to energy for you, or energy from waste, builds an asset. And after 20 years, he decommissions, decontaminates, and he goes out. And then you receive a land which is definitely 20, 30 times more in value than 20 years ago for many reasons. So just imagine any landfill in the Emirates. Imagine how it was 20 years ago when it was far away from the urbanization and from the city, and now it becomes in the heart of the city. And imagine the value back then and now. So the person who comes and builds a waste to energy for you, either he hands over to you an asset after 20 years, or he decommissions, decontaminates, and goes home. And he gives you the same land, which is again 20 times more in value. The other guy came, built a landfill for you, and from the moment he dumps the first kilogram of waste in this landfill, it turned into a liability. After 20 years, he is returning this liability back to you. And unfortunately, many people don't realize how much it is costly to remediate a landfill. You're talking about billions of dirhams. In some cases, some landfills that we have inspected will cost you 6 billion dirham to remediate and 8 years to move. And where are you going to move it to? You're going to move it to another remote land that after 20 years will become a prime location, and you will go over and over again. So if you want the waste to energy to be put in the right context, you have to study the full life cycle of the alternative solutions. And then definitely you will find out that even if you double the sales price of the electricity, you are making much more benefit to the society than the alternative.
Yeah. And I think just to reinforce that point, if you bury material in the land, particularly organic material, it will go on decaying for 30 to 40 years. So it'll be emitting the methane, the sulfur dioxide and the NOx long after he has closed the plant down. So unless you also fit gas harvesting and continue to run that, then actually environmentally you continue to pollute after the waste disposal mound is capped off and left. It still carries on decaying, still carries on emitting.
But even if we simplify it down to the direct monetary concept, you can see the difference between now and 20 years. And as I said, if you are going to remediate landfill X, pay 6 billion dirham and pay another 500 million dirham to build another landfill in a new location, then it is fair to say, okay, let's take the 6.5 billion dirham, divide it by the quantity of waste that we disposed in this land. This is the additional tipping fee that should have been paid to the waste to energy from day one, and only then you have two equivalent. They are not equivalent when it comes to the ESG and environment, but at least commercially, from a monetary perspective, this is how you make, this is how you treat waste to energy, treat it fairly in the right context.
I think the way Dubai Municipality has established our plant under the concession agreement that we have with them, what they've done is they've set the gate fee below their fee for going to landfill. So effectively, a ton of waste going to landfill has to pay about 100 AED, but it's only 80 AED coming to the energy from waste plant. And yet that gate fee still enables us to be a highly profitable and value-adding business. So I think it's effectively a win-win, because Dubai Municipality is reducing its landfill costs and using the difference between the landfill cost and the energy from waste cost to actually save themselves money per tonne as well. So effectively, Dubai Municipality is better off by 20 AED a tonne for every tonne it sends to energy from waste.
Okay, I think that was a really interesting conversation, and I think we've learned a lot here about how to turn waste into a resource, how to look at different aspects of its life cycle, and also, explore when it comes to energy from waste where the real value is for that. So thank you, Tim and Dhaka, for your time. This has been a Future Energy Insights podcast brought to you by the World Future Energy Summit.